All right, welcome back. We are COMP2142. That's game AI 1 in the winter 2026 semester at Georgian, and it's week 9, part 2 of our broadcast and recording. In the last part, we went over extensively graphs. We also talked about Dijkstra's algorithm, really, very short form. This is Dijkstra's algorithm here. We went through that. We also talked about priority queue a little bit, and now we're into our lab time, which is mapping neighbor tiles. But before we get there, I want to do an exercise with you, like I said. So I want to start off with, I want to create this priority node and some of these things, which is something that I want to make. Now it says priority node struct. I want to make this in, if we can, right? Can we do this, explore how to do this in Blueprints. So again, I'm using this project, and I've got kind of some stuff we've already made, a blueprint class, and we've also made a stack class. So you can see that these are both of type object. That's what they are. And I want to make another class. So I want to, remember how we did this last time? I went to blueprint class and I chose object. That's what I did. And then from there, I click select, and we can call this BP underscore priority node. And now my question when I'm making these things is it possible to do everything from C++, in Blueprints? And as you're going to see, it may not be 100% possible. So that's why sometimes we need to use C++, my friends. So why? Well, let's see what this little struct or class is going to do. We called it a struct. In our case, we're making a class because we're using, Blueprints, and I want to make a constructor function and all that kind of stuff. But the biggest problem is this part, this overloaded operator stuff, right? Can I make a way of overloading an operator, as an example? So if I type overload, right, there isn't a way of doing it this way. If I was to define a less than sign here, you can see that I have to choose a less than operator, and it uses math nodes. That's what it does, right? So that's something that I can do. Less than or equal to date time, I can use this kind of stuff as well. So that's one. If I want to create a function like that, I could try, but it's not going to do it for me, right? I'm just being honest with you. So when I just look at this thing for the first time, just to create a priority node, right? And there is no way, right? Even if I take the context sensitivity off, and if I even type the word operator, okay, this is the thing that you need to look at, right? So set operator field, cast operator field class, as an example. Here's operators. That's what this is, right? As an example. And now there are some things here, the field magnitude and the left field and the right field and all this stuff, get operator, set operator, right? Kind of a group condition, right? So here's set operator and or an exclusive or. That's something we can do here, but there isn't really a method to overload an operator as an example here at all. And if we don't have a way of overloading an operator, then sorting becomes impossible. And if we can't sort, I'm just exploring this with you. If we can't sort, then we can't really do a priority queue with a T array. So that's an issue, right? And that's what first thing I'm doing. So before I even start, we're stopped, with this kind of stuff. Okay? So does that make sense? Like, we can't really do it unless we can create a priority node. The thing that it's missing is this core thing here that's stopping us from comparing the G cost to the other stuff. We won't, or we have to, here's the other thing we have to do, create our own sorting algorithm. That's another way we could do it. If we can't do it this way, then we could use a sorting or searching algorithm, but we'd have to make our own, which is like sort priority node. That's the kind of thing we'd have to do. And then that would be another further data structure with like a lot of details only in Blueprints, just to make it work in Blueprints. So this is a big issue, okay? There is no priority queue that we could make, kind of in Blueprints itself. It doesn't exist. right? Because again, all we have is these three structures: T-array, T-map, T-set. Those are things we can make. So if we were going to start with this priority node, then we wouldn't use blueprints at all. Let's get rid of this, right? And let's see if we can use part of this, right? Part blueprint and part C++. All right. So, so what I mean by that is, I mean, we have this project, and this project is a C++ enabled project. We talked about this in the beginning, right? So I'm going to say File, Save All, right? And what I want to go to is I want to go to Tools, and I want to open Visual Studio here to grab my C++ side. Okay. So I want to look and see what I got. Okay. So I want to make a class. That's what I want to do, right? I could make it a struct as well, but I want to make it a class. And in my class, I want to do that overloading operator thing. Okay. I want to be able to do that. So once I have that class and it's available to me, then I can use it. I can call up that class and I can instantiate an object of that thing and do it, right? So I just want to do that one thing. The priority queue, the priority node is what I have. So here in my, you know, kind of my structures here, if I go into the starter project, you can notice that in my source, I have both a public and private folder. And the private folder, I have, I already have something called a priority queue that I've created for you. Okay. I'm not sure if you noticed it before, but you know, it's there, right? And the priority queue, I have it there, but let me explore how I did it with this thing all together. So if I go into priorityqueue.h, again, this is going to be in our week 9, right, project. If I go into priorityqueue.h, let me explore what this looks like. So how do I do the sorting? You know, as an example, if I can't do that, you know, kind of the thing that I want to do. Well, so I have the U priority queue is what it's going to be called. This is the structure that we're going to be going through. And I have a onQueue and dequeue function. I have a clear, peak, is empty, is not empty, and get size. These are all the same things that I had before. In the private section, I have a T array of type T object pointer, which is of type tile. So each tile, it kind of has it in there, and this is the queue itself. All right, so it's private. So that's one thing I have in here. And it also forward declares the tile class because I don't want to necessarily. Am I hallucinating here? Hold on a second here. Week 9, yeah? Yes. Okay, good. So I don't want to necessarily, you know, kind of, so I'm sparking out there for a second. I don't want to necessarily, like, you know, do all the heavy lifting for you kind of thing, right? But this is where it's going to save us some time. Okay, so that's what it is. I want to look at the priorityqueue.cpp for a second. So here's the onQueue. So the onQueue, right? One thing that we can do when we're sorting is we can specify how to in the sort algorithm. So queue.sort, it has several overloads. So this is another thing you can do with the sorting algorithm here in C++. Instead of you making a custom comparator or overloading the an operator, instead of doing it here, one thing that you can do is you can create a lambda expression, and this is what this is, where we're using a lambda expression to basically take tile A and tile B and then do the comparison where we take the two costs together, and you'll see what H cost is in the future. H cost is going to be the heuristic distance with A star when we explore that next week, and we compare them that way. Okay, and once we've done that, then we just remove the queue at 0 as normal. So that's what this does. All right, so that is the priority queue, and it's already there. I've put it in for you. Instead of you having to build it yourself and trying to figure out how to create a, you know, an overloaded operator to make that work, yes, you could do its own. You could create its own. You know, do it in the tile class as an example. Each tile is your priority node. That's what it is. So I could have, in the tile class, let's go back to that tile.h and tile.cpp. In the tile class here, what we could do here is we could overload an operator in here, so we can do the custom comparison in here instead of the way we did it, and just use the regular sort function, and the sort function would figure things out for you. Okay, but instead of doing that, I just use a lambda expression in the Q class, the priority Q class, to do it for us. And a lambda expression is where we kind of write it. There's a, what it says here, exactly what it is a predicate, right? And what the predicate is we pass a function. This whole thing right here, right, is a function that we pass into the sorting algorithm. And what this does is it returns a Boolean. So it actually, it kind of like is a custom comparator built in, where the square brackets is the lambda expression, right? It basically has, it's an anonymous function that we write that gets analyzed at sort time, right? So every time sort is called, then it uses this predicate or this lambda expression, and what it does is it passes in A and B, references to tile A and tile B, and it passes it into the body of the function, which returns if the cost of A is less than the cost of B. It returns a Boolean. Notice that that arrow function at the end, it shows an arrow bool. That means that's what it's returning out, and it returns it back into the sort algorithm, and it's going to compare each object inside of the priority queue. Okay, that's what it's going to do. So Q itself, right, as an example, because it's a T array, it allows you to sort all the elements of the array, but there's a bunch of overloads. So if I was going to go into Q.sort, then if I open up kind of the brackets here, one thing to note is if I hover over, it could take a predicate because our Q class is custom, but kind has the sort algorithm. It's the sort function has multiple overloads, right? Because it's an overloaded method, so it could just take nothing like this, right? But this wouldn't do anything. It wouldn't know what to do because it needs some kind of overloaded operator. So it's like going to go, man, I don't know what to do, kind of thing. So the predicate structure here, this pattern actually tells it what to do. It basically says, look, take A and B, the two tiles that you're going to sort when you're going through the list of elements, and then it figures it out for it. That's what this thing does. All right, so again, if I run this thing, it's pretty simple, right? All it does right now is this, right? And it doesn't really have a neighbor tile or anything else. It has these two classes that we made last time, but my intent here is to show you that it's not always possible to do it in blueprints. It's just not, right? I mean, you could do it, but it's going to be like really long and crazy. And I think sometimes we have to revert back to something that's simpler in C++. It cuts down on some of our work and makes it so it's possible. Okay, so that's what this is. This is like a possibility of how it's working. How do I use the priority queue? If I made it, and we're going to do this next week, but how do I use it, in our project? Well, we don't need this now. I'm showing you this so you can see it. I'm going to go back to C++. In my blueprint, let's suppose I have my grid character, and I want to use my priority queue, right? So one thing is, if I type in priority queue, can I access it here, kind of thing, because that's the one thing that I want to be able to do, right? So again, I just want to make sure I'm not crazy, because I'm looking at this, I'm going, wait, something is wrong. Yeah, so what I've done is, that's what it's going to look like, as an example. I haven't added that into our project yet. Okay. Right now, what we have is grid character tile and tile UI. Where that came from, I have to be honest here. When I'm opening up this thing, when I said open up C++, it looked at another project. I don't know why. Sometimes Unreal Engine does that kind of thing. That's why I was looking at it going, Huh, I already have this in there for the guys already. Haha. Yeah, no. So sorry, let's try that one more time. I'm just going to close this down. So file, save all, and this will be the better way of doing it, which is I'm just going to open it up from the project. But that's what it's going to look like next week. I'm going to make it with you as opposed to you doing it on your own, because I think it's just, you could do it. I'm not saying it's impossible for you to create it, and I can give it to you to do, but I just think that it's probably overkill for what we need. Yeah. So I'm just going to double click on this, because you know what you need. You need a priority queue, right? But instead of us making it together in class, which can take quite a bit of time, I'm going to give it to you. Okay, I want you to know that this is what we would have done. But here, I want to explore how to do it a little bit by hand. We can make our project structure for a second work. And what I'm going to do here is I'm just going to wait till this loads, and then Control F5 to load it from Visual Studio, which will have the proper Visual Studio markers in there, as opposed to what we did last time. So let's just do Control F5. The Unreal Engine editor is closed, and then it'll pull up UE from Visual Studio. This is assuming that your project will be able to build, and you know your computer at home is set up for this. Again, just like last time. So it's building. I just gotta wait. So I looked at this, I was like, wait, this doesn't, I don't know where I got that from. It must be from my other project. Okay, so it's launching. It's taking a sweet time to launch, but it's launching. All right, it's almost there. So I'm doing it this way because I want to reduce the chance of error as we do this. And it's just for this exercise for this week. Okay, so, you know, just to get to this. So what I want to do is I just want to create the priority node that I want to talk about before. And then we can work within our blueprints the way we normally would. Okay, so how would we do this? Okay, so we don't need this. So in the, so I'm going to go back to data structures. I have these two things. And what I want to do here is in my C++ classes, I want to make a new C++ class. So I'm going to go Tools, New C++ class. And again, when you think about where it starts from, all right, so an empty C++ class with a default constructor and destructor, no. I can go to all classes and choose object, right? Because that's what I would do. Okay, so that's for the object class. So it's going to be a little different than what I have here in the PowerPoint. Instead of it being a F priority node, which is a struct, I'm going to make it a U priority node, which is a class. Okay, so that's the only difference I'm going to make. So let's try this. I'm going to make it so it's a class called priority node. So let's do that. So click next. Now notice that I have, I want to put this in public. Public is selected because my project is split up between public and private, right? It's going to put whatever I have in here. This is the first time we're doing this, you know, inside of both the public and private folders because we're splitting it up this way. So going back to this, then I want to call it priority node. not F priority node, just priority node by itself, right? So, so that's what this is going to be. Let's get rid of the F. Okay, priority node, and then click create class. It's going to take its time, and it's going to create this for us for a second, and then we'll have this available to us. Once it creates it, we'll need to rebuild, and then we'll have that priority node. Then we can create our priority queue inside of blueprints, because the only thing we need is the ability to sort, right? So let's see how that works. Okay, it's ignoring, blah, blah, blah. I'm just going to wait where it goes here, and it says reload. So what I'm not happy about is the .h is very sparse. It gives us priority node .h, and it's like there's nothing. It's not what I expected, right? We'll see how it looks in a second. Let's take a look. One day when it feels like doing its thing. Yes, this is what I'm looking for. That's good. All right, so so a couple things. Let's just get rid of the stuff we don't need. We don't need that stuff. Still building. Come on. And don't need all that. So now one thing is that it says U class, and it says U priority node of type U object. That's what it is. It's got a generated body, and now what we need is two parts to it: a private part and a public part. Now, because this is we're going to treat it like a struct. What we're going to do here is we're going to use public. So back to this, we're going to use the public area here. And the public area is going to have, first we're going to talk about the, the constructor function, which is priority node. So we'll do that first. So U priority node, right? That's the constructor function. Now we don't want to make it the empty constructor or the default constructor. We want to take in an in node index and a in gcost. So we'll take these two things like so. And I don't want to write it in one, but I want to do one of these, right? And then we'll have a .cpp that does the rest, right? Now it's kind of coding for me. It's telling me we need these two things. Well, here they are. And so these, the node index and the gcosts, I want to make them public too. I don't want to make them, things. So I'm going to put them in here in the public area. So these two things. So we're going to do one of these. Okay. So int, and these are properties that are public, right, as an example. But if we want to access these from blueprints, then we would, if we wanted to have in the node index and the gcost, we would call that exactly what it is, node index and gcost, right? And if we want them to be available to us per node, like get and set, then we'd make them public, like so, and we'd make it a U property. And we might do something like, blueprint, read write, edit anywhere, and most likely would probably say something like properties, which is where they would go. Okay, so that's a U property for this one, and we'll also do the same thing for the other one. Okay, so that's the two properties we have plus the U priority node. Where it gets tricky, right, because we have the constructor function now, is this operator. Okay, so this is where the overload is going to be interesting. How do we do this using Unreal Engine's version of C++? Remember, because C++ scripting is what we're doing. So I want to make it so that, just like we say here, it is bool, and I want to make it so it's operator less than, and we can write it in line like this, right? And it kind of wrote it for me, where it basically takes U priority node other, and then takes the gcost and takes the other gcost and creates this overloaded operator. So that's what this is, right? And this has been written in line like this as well. To write everything in line is okay if I wanted to do that, but then I wouldn't need the CPP, at all, right? So I could do it so that the uPriorityNode constructor function is also written in one.h, as an example, so we wouldn't have to load in the CPP at all. But we're going to do it differently. We're going to kind of set that up here, right? Now, could we do it this way as well, where I want to write in the operator overload in the .h? I can kind of do one of these, and then I can write this part. Can I do this part in the .cpp? I could. It's possible as well. So I could do it this way. I could kind of note it this way. Operator less than. Notice that there isn't a U function or something like that. I don't want this necessarily to be something that I expose on the blueprint side. So because I'm not making something like that, I don't have to mention it as a U function. U function and U property use the reflection system to allow me to access objects, kind of thing from blueprints. That's what I want to do. Even the U priority node, the constructor function is not something that I need in blueprints. Therefore, I wouldn't create it as a U function, right? All right, so that's one. And then what I want to do is, of course, I want to go to the U priority node and I'm going to use ReSharper to generate definitions. So it's going to ask me to do these two things. I'm going to press finish, and it's going to put them inside of my .cpp. What I want in this case, I could do this, but I want to create the thing that we had before, which is this is our initialization syntax. We can use a colon with what this is going to be. Okay, so that is our priority node save, right? And what I want to do here is, because we created this thing, which is really important, I'm going to file save all here, and I'm just going to close this off and restart. So Control F5, right? And then let's relaunch in Unreal Engine. So now we have that thing that we couldn't construct properly in Unreal Engine. We can do it in C++, and then now in Unreal Engine, do we have access to it? How close are we to getting it to work? So I want to do one part of it in C++, but then the other part I want to do in Unreal Engine completely, kind of thing, which is purely in blueprints. Is that possible? So a bit of an exploration. Failed. All right, so let's take a look here and see what it says. Why did it fail? Priority node.h. It says static assertion failed with you have defined uPriority node or uPriority node priority node const f object initializer. This is required by uObject system to work correctly. So this is a bit of an error. Yeah. So this is what's missing, right? Right here. So it says, it's telling me what I'm missing, right? That there's a piece of my uPriority node that I'm missing, where I have to define either this or this, which is an empty constructor. So because we're making it this is a non-empty constructor, right? If I go back to my priority node, that's what it's missing. It's calling for uPriority node by itself, just like this. That's what it needs. And so what I can do with this is I can generate the definition for this, which is an empty constructor function. I don't have to put anything in there, right? But that is a way of instantiating. Let's try this again. So let's save all and then Control F5. Okay, so let's see what this says now. So it says you have to define a uPriority node or uPriority node priority node, right, with const f object initializer, and this is required. So I didn't quite take care of it, right? So it looks like it says members, node index, and gcost are not initialized with this constructor, right? And that's why it's got this underline, right? All right, let's see if we can do that. We'll set them up as some, some things. So we know that in node index, right? When I look at what that is, in node index is a integer, and in gcost, right, as an example, is an integer. We can make them 0, right, by default. So we can say that we can initialize both of them to 0, which satisfies the initializer. All right, so let's try that again, and Control F5. By the way, all these things, all these errors are expected. Okay, so now it's the next error that we're going to get. And remember what I said, which was, can we do it? All right, so it says, just going to go back down to stuff that makes sense for us. Okay, so we have these two constructors, right? And it's just going to kill this little line here so we can see what the problem is. There doesn't seem to be any errors, but we have two constructor functions, and we have this this overloaded operator thing that we're trying to do here, right? And then we have this overloaded operator part here. We have these two things here, and then in the error list, if I go down, so it says asset editor subsystem.h, where t optional bool is not allowed. And so what potentially now is causing my issue, because it doesn't make any sense. It says, well, await mutex. It says engine build, batch files, and it says that this is a weird kind of error that says it just can't build. That's what this error is, believe it or not, right? And then it says preprocessor command must start at first non-white space. That's priority node, this one. So it says the preprocessor command must be up here, the first non-white space, right? And that's what it's trying to get to, right? So I messed up, and it's looking like I should just do this. That's what it was. All right. So let's do this. Pragma once. Pragma once basically allows me to go through and kind of ignore this file if it's been included twice. That's what it does. Let's Control F5 here. That was my mess up. And try again. Again, you have to read through the error codes. ChatGPT and that kind of stuff will help, but you need to understand what those things mean if you're going to be a program in C++. C++, I know that some people have said it's pretty scary. It's just a matter of doing it over and over again, and then kind of you get it. But it takes time, and it takes you putting your reps in. All right, so now that we've got this class, if I go through the classes, right, and I look in the public area, I can see that I have a priority node. All right, so hopefully you're with me. Let's put this up on DevOps so you have this as well. So I'm going to say git add dot git commit -m, and we'll say added priority node class. There we go. And it added those two little files there. That's all it's doing. Now, do we have access to it if I make a priority queue, right? Do I have access to the priority node, right, that I want to make my priority queue out of, right? And I want to do the blueprint part now, all right? So I don't have to make a priority node. I already have this, right? How do I do it? So back to blueprints, and I want to go into my data structures here, and I want to make a new data structure, a new blueprint class, which is of type object, right? Which we're going to call BP_priority queue. There it is. And let's do that. We kind of overcame that limitation of doing that. Okay, now we've already done this part. This part's done. We did it in C++. Can I do this part? Can I make a T-array of priority nodes? That's my next hurdle. Can I do this? Now it says private, and that's fine. But how do I do that? So going back to this, I want to make a variable, which is of type. And we're going to call this a queue, right? Now, I know that this is called queue, and it's of type priority node. So let's see if I can do this. If I type in priority, does it come up? And it says, well, not really. So I'm making a queue of type. It says priority queue. That's what I'm making right now. So I can't really do it this way. I can't like, you know, create an object of type, you know, priority node, right? That's in here. It doesn't see it, if you will, right? And even if I was to do something like, you know, construct, right? You know, like I want to construct or build something in my event graph, right? So construct object is what I want. There it is, object from class. And then in here, I want to kind of put in priority. You can see priority queue is here. Priority node is what I'd have to make. So I'd have to make an object from class, which is a priority node. I can do this, priority node, right? That comes up. But to make a queue, which is an object, you know, that's here, how do I do that? So I can right click here and I can promote this to variable. Let's do that, promote to variable. So here is this object. So that's something I can do, an object, right? And this object is what it looks like, because it kind of sees it as an object, a class reference, right? That's what this is, a class reference. So, okay, and here's the, let's compile and save here. And then the class reference could be of type priority node. That is okay, right? It's just, it's jumbly, you know what I'm saying? So I could do this. I don't need to do this anymore, right? But I could do this because this is of type, it's of a class of priority node, right? And well, I don't want to make it a single. I want to make it an array. So this is the way I would do it, like so, right? So this is an object, priority node object class. That's what it is. And now I can get rid of this. Okay, so this is the queue, right, which is some stuff that I'm going to create. So this is, if I pull in queue now, so get queue, then I could do things like add, right, and I could add, it says add what to it, a class of whatever it's going to be. Not easy, right? Again, it's kind of confusing that how this works, and so you can see what this is, a queue, an object. Okay, so let's try this again. So that didn't work. Okay, well, what if I did it so that it's instead of my queue, instead of an object, so let's type object, and it has to be object references, not object classes. So I'm going to go object reference, right? An array of object references, compile and save, right? And okay, so it's an array of object references. Let's actually not make it public, let's make it private. Well, yeah, but what object is it? Well, here is the objects that I can take any objects in there at all. This is an array of objects. Okay, so that's kind of weird, because if I was going to sort this array, so if I did something like queue and then I want to do something like sort, notice that I can add, and it says, okay, well, what am I adding? What thing am I adding? I'm adding any asset I want. I can make this an array of objects, so it can be anything, right? So that is what add does with a queue, but it doesn't allow me really to, you know, create a queue of priorities. So if I said something like priority nodes, it says priority queue. I can't do it that way. So what this beckons to me, what this makes me feel is, oh man, you know what I need? Another blueprint. Bear with me, guys. Bear with me as I work this through, and then we'll go into the other thing I want to do with you. So let's make that. So let's make a brand new blueprint. So we'll say blueprint class. Instead of picking object this time, let's pick priority. And notice that priority node doesn't come up. So why not? So, okay. This goes back down to the way we've constructed. I'll leave this here. I'll save this. I'll file save all. And let's close back down our Unreal Engine for a second and go into our Visual Studio. So notice that U class up here is a modifier. It's a, you know, again, this it is a macro that brings the uPriority node into our kind of system. And what we can do is, if I go into grid character is also a U class, right? That's also possible, but grid character somehow is available, whereas priority node. So let's bring up grid character for a second. Here's grid character. Grid character is of type U class, and here it is, public A character type, right? And priority node is also a U class, which is of U object type. Okay, so there's no blueprint derived classes, it says, right? And what I want is I want to create a blueprint class from my U object, like I've done before, right? So how come I can't make it a priority node, right? Well, there's some objects here. So if I kind of open this up, notice that there is blueprint type, which I could add in there. So blueprint type, if I hover over, it says exposes this class as a type that can be used for variables and blueprints. This is inherited by subclasses unless overridden. So blueprint type. Okay. So save that, and let's see if that helps. Control F5, to help us build out this thing. One more time. By the way, I'm not trying to chase a rabbit hole here. I'm trying to show you something. So bear with me, right? And this is all in the pursuit of making pathfinding easier. Okay, back to we have priority queue, but let's see if we can make our priority queue class. Here's our priority queue class. And let's see if now I can make a variable of type priority node. So let's see if I can do that. I'm going to make a new variable, and we don't care what it's called right now, but I'm going to call it, if I start typing priority, now priority node is a thing. Does that make sense? So I had to expose the class. I didn't have to do that for character, because character is already exposed. Character is the superclass of our grid character, and character and actor and all those other classes, as an example, are the superclasses of those things. So they already have been exposed. But now I want to make a priority node object reference, which I want to call Q. There it is. Okay, there's my priority node object reference. I don't want to make it one, I want to make it an array. There we go. So now it's coming up. Yay. And now, can I do something with this Q? Can I sort this Q? And this is the next problem. I can add, right? And all that kind of stuff. But, and if I was to type in anything, like these are all the, kind of class variables. This is my, Q, right? Here's my priority queue. That's one thing. Utilities, right? So I can set and my variables. So this is what I can do, right? With my queue, I can add, I can remove, right? I can do all those things, but sorting, my friends, is not an option. Even after I've made my own, comparator, which is my custom overloaded, operator function. It just doesn't work. It doesn't come up anyway. So notice it says array sort, and it has sort that's built in. If I take context sensitivity off, it will sort certain things, right? So I can do sorting a byte array or an integer array or a name array or a string array or a float array. It understands how to do that. But in blueprints, we've never defined how to sort, this kind of thing, right? So even though we have the sorting capability that's built in, can't do it. And that's a problem. So again, now that we've been able to get to this part, we're stymied again. Okay. Okay. Right? And also the other thing is, if I do a less than, kind of thing, you see that there's a less than here. So if I do less than, and if I say something like get, if I do a get, let's just do a proper get. So here's a get a copy, and I get this thing, and I want to say that this is less than something else. Notice that I can't do this. I can't compare one object to the other. I could say manually, I could do something like the object, so I can break, or I can, because this is an object, I could say get cost, or the G cost, if you will. Get G cost, because G cost is part of this object. This object breaks down into G cost, and it also has the node index. Those are the two things it has. So G cost can be, I can use a less than sign here because that makes sense. I want to be able to do this, kind of thing. I compare my G cost. I have to make my own sorting algorithm by doing it something like this. So it's, again, a much longer process. Where, I'm only sorting 7 elements in this case because or 8 elements because I'm only looking at the, those things, but still it's quite complex. Okay. So it's going to get messy is what I'm saying. Okay. All right. So this doesn't work. All right. And let's compile and save here for a second. And let's save all one more time. One more check. Save all. And I want to close this down. And I want to go back here and my overloaded operator. What if there was some way of using this as a U function? Here it is. And blueprint callable? No, let's just make it a U function, just like that, by itself. And so we're not going to specify what it is. We're just going to do this. Now, it tells me there's an issue. It says found end of file while parsing, right? Well, that's only because it's trying to figure this out, but there's nothing to parse necessarily. So let's just save this. So U function, remember that it doesn't need like anything, right? I could put in something like, blueprint type. I could put that in there, right? But that's not going to save me either, right? So again, let's just try this, Control F5, and let's see if it's going to fail. And it does. It says, nope, sorry, I don't know what you're trying to do, Tom, because it says, end of file while parsing function return type and function in class. So back to this, if I was going to go to our priority node, which is this, here is our return type. You can see that, this is what this thing is. It's a const, and I'm returning a G cost is a bool, right? And it doesn't know how to handle this at all, right? That's why it's telling me found end of file while parsing function return type in function in class. So it's kind of trying to figure out what I want to do, right? And again, it doesn't matter what I put in here. If I put in something like blueprint callable and whatever I want. Let's just put blueprint callable in there. Notice that there's nothing that will do it, even if I put it under category properties. Let's do that. Right? And I do this, it's not proper to return a Boolean and have operator. This doesn't compute. It doesn't allow me to use this U function or make one of these. So one thing that you can always try is you can do one of these, like where GitHub Copilot is built in, right? So let's suppose I said it's possible. I want to open up a chat window here, and you can actually ask it what you want. So you can say, I want to create, check this out, want to create a overloaded operator for sorting purposes in Unreal Engine. So it's going to take that and see what it says. It says I can help you do it, right? And it says, so it says, looking at your priority node class, I can see you already have a priority declared, and it's going to give you some recommendations. So GitHub Copilot's really come a long way in that you can do it right in here. It actually has a context and everything else like that. So and it'll basically make a recommendation. It'll say, like, do you want me to accept these changes or not? You know, kind of thing. So let's just park this thing down here. There we go. And it says, I'm just going to read this for you. So it says, da 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 da, I want to create overlap, da 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 da, and then it has all this. It says, so it basically wants to define all of them. It doesn't just want to define one. It wants to define them all. Less than, equal sign, not equal, the whole thing, right? So TRA sort, use the operator for ascending order, and la da da heap sort. Okay. I can say, okay, this looks good. By the way, I'm using Claude Sonnet 4.5. What this does is when you register on GitHub, right, then it allows you to use some of this stuff. Notice that these are old. By the way, Sonnet's updated to 4.6 at this point, right? So if you wanted to do this on Visual Studio Code, it would do it. The problem with it, here it is, here's 4.6. The problem with this is it will charge your GitHub account, right? So it kind of gives you a free usage for a bit, and if you've signed up with GitHub Copilot, and then the rest it'll start billing you. But okay, this looks good, but I can't seem to use the sort function in Blueprints, and it's going to tell you why you can't do it, right? So because it just doesn't allow it won't work, is what I'm trying to tell you, right? It's got to be something that you do on the C++ side. I've at least at this point in time, even with a bunch of help, maybe Claude Sonnet's going to figure something out, right? But I doubt it. It says, all right, so it says the solution is to create a U blueprint function library with a U function that exposes the sorting logic to blueprints. Come on, it's crazy, right? And it's giving you a suggestion about how to do it, right? So it's giving you some files. It says, so U priority node function library, you'd make that. It's giving you what it would look like. And then what you want to do is you create a, a function called is priority node less than, right? And sort priority nodes. And basically what you would do is you would call it, look, it's using the lambda expression right here. So if it's using the lambda expression to sort my stuff, I mean, I might as well write this stuff in C++. This is the exact same lambda expression that we saw last time in my previous code. See that? Moral of the story here. It was a nice try, all right? And, but there's just some things that you just can't do properly without using C++ and Unreal Engine. You just can't. And we'll see more of that as we approach multiplayer in the third year, and as we approach some functionality, for example, the gameplay ability system really requires C++ to work properly, in Unreal Engine. There's just some things you just can't do properly. So yeah, we created a priority node and it comes up, but it's not usable. Questions around this? And I'm bringing it up as an example. I don't want you to really necessarily do anything with it, but the problem that we have is it can't. So that's why next week I'm going to give you my, my priority queue. It's going to be ready to go, and then you just construct a priority queue and you're good to go. Okay? Because otherwise it's going to be wasting your time. You're going to spin your wheels trying to do this kind of stuff. At least if you're going to do it manually. Thoughts at all around any of this stuff? Let's get rid of this thing because I don't want to do it. And let's move on to the next part. So that was this. I wanted to show you two. And now what I want to do is something else. I want to map our neighbor tiles. We'll do that for the last part of our day today. So one thing that we have that you should know is in tile.h we have a set neighbor tile function already defined for us. I already made this for you in C++. right? And what it looks like is we can pass in an neighbor tile enum, right? Which basically is top right, right, bottom, and so on. That's the enum. And the tile reference. That's what it does. So it's kind of built in for us. So here's what it would look like if we were going to do the top neighbor tile. We'll go into our grid character. All right, so let's open up our grid character here. Here it is. And inside there we have our build grid function. Here it is. And this is what we were looking at last time. At the end where we toggle visibility, right, I want to add in a sequence node. So here's a sequence node here. This is where it goes in the build grid function. And the first thing I want to build is I want to get my row int. So get row int. There it is. And just like it says here, I want to say that for the top node, if my row int is 0, right, if that's true, branch, right? In this case, this is one possibility, that if I'm at the top row, there's no top reference, right? So I mean, that means that what I mean by that is if I look at the grid, let's run this thing for a second. And if I go way at the top, like this one right here, top left corner, this top left corner here, there is nothing above it because we're here, we're at the top. So when our row is 0, we can't look up. It's blank, right? It's a null pointer, right? So that is the true case. If my row integer is equal to 0, then true. We can get our tile, get tile. Here it is. And what we can say is we can set neighbor tile, the top, to nothing. That's our first case. The second case is if it's not true. Let's say, for example, we're not at the 0th row, we're at the first row, right? In that case, we do have a tile above us, right? So that is the second case. So we want to do the same thing, set neighbor tile, right? But we want to give it a position. The position is top, but the tile that we want, which tile do we want? What we want is, I want to use that get tile from grid function. So get tile from grid, and that is the tile that I want to pass in. So I need a column and row information. So where I am, I want to have the same column that I'm in. I'm not changing columns, so it's going to be column integer, get column int, right? And the row is going to be above me, so 1 minus. So I'm going to get row int minus 1 for the row. Okay, so that is what I've got there. Okay, and this is a mapping for the top neighbor. So we're going to say that set top neighbor. The Canadian spelling, please. All right, so that is our top neighbor. So this happens for each tile because we're inside of a set of for each loops. That's what we're doing. So here's a for each loop, here's a second for each loop, and then we're making it visible or not for each tile. So for each of the tiles, I want to start mapping its neighbors. This is our neighbor mapping exercise, right? So if I compile and save, and let's run this, right? If I run this, then the way you check these is these tiles are generated. If I go to tile 0, then, and if I look at neighbors, right, you can see that tile 0's top neighbor, because it goes top right, bottom right, bottom left, top left, right? Those are all the neighbors, okay? In that order, by the way, and I have an enum to show you this. There's no mappings because I'm at the 0th tile, this one up here, right? Well, let's check the 40th tile. What does that look like? So you can skip down to the 40th tile, and when you click onto it, look, it says tile 0. So the 40th tile, which is this one, points to tile 0, the one above it. So it's good. And if I want to go to the 80th tile, then that one points to tile 40, the one above that. So that's how we map the top neighbor. Okay, challenge for you guys. How do I map all the other ones? Top right, right, the bottom right, bottom left, left, and top left. Can you think about what we need to put here? So again, what you can do is copy this and put it in place. Undo, put it in place. So this is what I would do. Change the comment to top right. So set top right neighbor. Let's connect it. And let's think about, let's put all these in there too, these reroute notes. We need them anyway. We need to think about what we need to do here. So for the top right, we need to change this from top to top right. This indicates which of the tiles we're using, which tile in the tile array, in the neighbor array, which neighbor in the neighbor array, top right in this case. And what are the conditions? Okay, well, so I'll do one with you. So here's one. So my row integer is 0, right? And, or I'm at the right edge of my, my tile, which means if I was to run this for a second, let's just run it, doesn't matter. That means if I'm here is also a problem. This is a case. So this case here, if I'm at the top, there's nothing on the top right. All the way to go to here. If I'm here at the right, then there's nothing up here either. Whether I'm at the top or I'm here at the right, let's say for this one here, there's nothing up here. There's nothing from here to here, right? Which means that we need to change the condition a little bit. Let's move the condition closer, right? And we'll undo this. So this is one possibility, but the other one is when the column int get column int, when the column int is equal column number, in this case 40, minus 1. So when I'm at the edge, the right edge, that's what this is. So when I'm at 40 minus 1, which is 39 in this case, right? If the column int is equal to this, right? So this is an or, this one. If either one of these conditions is true, either this one or this one is true, then we would mark it as null. Let's make this a little wider, and we'll move some of these things out because we need some more space over here. And we might as well just do this one the same, just to make it so it's the same size. And I'm just going to move all this to the right a bit. There we go, so we can all fit in here. There we go. So that is the top right neighbor. This part, that's the check to see if it's null. The other one we want to check is, okay, now what do I do? It's not my column int and my row int minus 1. It's my column int plus 1 and my row int minus 1. So it's up above me, but to the right, right? So this is column int plus 1. Okay, column int plus 1 and row int minus 1. Row int, my row up minus 1 and my column plus 1. Right? That's what this is. All right, let's check and see if this is good, and we can check different ones to see which one it is. Compile and save. So we know the first row when we do this one. If I go back to the tile 0, all of these are going to have nothing in them. They're not going. These two are going to be both blank for all of them because it's the top row, right? So let's go then down to number 40, right? So row 40 is going to have both of them, 0 and 1. Why? Well, if you look at it, row 40 is this one. So it's going to have 0 for the top tile and 1 for the top right tile. So this is good. And we can look at all of them, how they increment all the way until you get to about 79. 79, you'll have the top one, but you won't have the top right one because it's at the edge, right? However, 80 will have both. So this works. Okay. Does that make sense? What I'm doing, I'm mapping one. I'm using this right winding methodology to map each of the neighbor tiles one at a time, or clockwise. I'm just moving clockwise. That's all I'm doing. Is anyone confused, or anyone needs help on this one? So your challenge is, can you do it by yourself? Okay. Now I have the solutions here. Okay, all the solutions for all the other all the things. I just did this one with you, right? This is the one that we just did. Okay, but they're all here, right? What I want you to do, take away, right, for yourself, for next week, is do it by yourself. All right, go through and do the mapping exercise and map all the rest of the tiles on your own, right? And try not to look at these slides. Try not to look at them. Try doing it on your own. Like, logic it out, right? Because once you do, it'll help you. It really will help you understand how I'm putting things together. If you can't figure it out, look at the slide and it'll tell you the answer, right? But I'd like you to try and do it on your own. Questions around this before we go for the day? So it's an exercise. It's not worth any marks. I know I could make it worth marks, but I'm not going to, right? It's for you. It's for you to try and to figure stuff out a little bit. It's important you guys try this out. I know I keep telling you to do this. Thanks, Alex. But I'm trying to encourage you to practice. The only way you're going to get good, like we said before, is to put your reps in with Unreal Engine and to really understand what's going on here. All right. You know, otherwise, you know, as we move forward and we continue to add more and more complexity, you're going to get lost. And I don't want you to get lost. I want to help you be found, right? So the only way that can be done is if we practice together. So please, I'm asking you, do it. All right, it's important for you to try to do it on your own. Any questions before we go for the day? Guys, thank you so much. I appreciate your patience with this process. I know that I went down a bit of a rabbit hole with some of that stuff, but I did it because I want you to understand there's certain limitations that, you know, it makes it unreasonable for you to try and do it in Blueprints when you can do it in C++. All right, guys, take care, and we'll see each other next week on Wednesday. And we'll be in person. All right, take care. I know, right? No Elden Ring. Take care.